Hello, dear listener. Welcome back to Sleepy Science Channel, where we explore the wonders of our world through the gentle lens of curiosity and calm. Tonight, we're descending into the deepest, darkest places on Earth, not to frighten you, but to discover beauty in the most unexpected corners of our planet. We're diving into the oceans, twilight zones, and abyssal plains, where creatures more alien than anything in science fiction drift through eternal night. Get comfortable, adjust your pillow, let your breathing slow. Tonight's journey will take us 7 miles down into trenches deeper than mountains are tall, where the pressure could crush a car, but life somehow thrives. We'll meet fish that make their own light, octopuses that vanish like ghosts, and creatures that have existed unchanged for hundreds of millions of years. If you enjoy these peaceful explorations into Earth's mysteries, a gentle like or subscription helps this channel grow, but only if it feels right. No pressure, just an invitation to join our community of curious, restful minds. Now, close your eyes if you'd like. Take a deep breath. Let the surface world fade away. Let's begin our descent into the deep. The ocean covers 71% of Earth's surface, but we've explored less than 5% of it. Think about that for a moment. We've mapped the surface of Mars in more detail than our own seafloor. The deep sea remains Earth's largest and least known habitat, a realm of perpetual midnight that holds mysteries we're only beginning to glimpse. Right now, beneath the waves, in crushing darkness, millions of creatures are living lives we can barely imagine. The deepest part of the ocean plunges nearly 7 miles down the Mariana Trench. If you placed Mount Everest at the bottom of this trench, its peak would still be over a mile underwater. The pressure at these depths reaches 16,000 pounds per square inch. Imagine 50 jumbo jets stacked on top of your thumbnail. Yet life exists there, thriving in conditions that would instantly crush most submarines. A world that should be barren pulses with strange, beautiful life. The giant squid can grow to 43 feet long. That's longer than a school bus. With eyes the size of dinner plates, the largest eyes in the animal kingdom, each one as wide as a human head. These enormous eyes evolved to catch the faintest glimmers of light in the deep sea's darkness, detecting the bioluminescent glow of prey from hundreds of feet away. For centuries, giant squids were considered myths, monsters from folklore told by sailors who'd had too much rum. The first photographs of a living giant squid in its natural habitat weren't captured until 2004 in the dark waters near Japan. But the giant squid isn't even the largest squid in the ocean. The colossal squid grows even larger, reaching lengths of 46 feet and weighing up to 1,600 pounds heavier than a grand piano. This massive predator lives in the Southern Ocean around Antarctica, in waters so cold and deep that we've only seen a handful of specimens, most of them dead or dying when brought to the surface. Its tentacles are armed with rotating hooks, not just suction cups, terrifying weapons designed to grip struggling prey in the absolute darkness. These hooks can swivel like claws, ensuring that nothing escapes once caught. Deep-sea creatures live in a world without seasons. Down there, it's always the same temperature, always the same darkness, always the same crushing pressure, a constancy unknown anywhere on Earth's surface. While surface oceans experience dramatic changes, storms, temperature swings, seasonal blooms of life, the deep remains eerily constant. Some scientists believe this stability has allowed certain species to remain virtually unchanged for millions of years, living fossils in a timeless realm. They found their perfect form eons ago and saw no reason to change it. The vampire squid isn't actually a squid, and it doesn't drink blood. Its name comes from its dark, cloak-like webbing and red eyes, which early researchers found unsettling when they first pulled one from the depths. This gentle creature, about the size of a football, drifts through the ocean's oxygen minimum zone depths, where oxygen levels are so low that most fish cannot survive, where the water itself seems hostile to life. When threatened, the vampire squid turns itself inside out, exposing fleshy spines that make it look less appetizing, transforming from vulnerable prey to spiky deterrent in seconds. It feeds on marine snow, the gentle rain of dead plankton and waste that drifts down from the sunlit surface, a peaceful scavenger in the eternal night. 90% of all deep-sea creatures produce their own light through bioluminescence. Imagine that a world where nearly everything glows, where darkness is punctuated by living stars. They create light through chemical reactions in their bodies, mixing luciferin with oxygen to produce cold, blue-green illumination that never burns, never consumes fuel as we know it. Some use it to hunt, creating glowing lures to attract prey like fishermen with luminous bait. Others use it to communicate, flashing patterns like Morse code in the darkness, conversations we're only beginning to decipher. Still others use it as camouflage, matching the faint light filtering from above to hide their silhouettes from predators below, becoming invisible through light itself. The anglerfish is perhaps the most famous deep-sea creature, and for good reason. Females carry a modified dorsal fin that dangles in front of their mouths like a fishing rod, tipped with a glowing lure filled with bioluminescent bacteria that live nowhere else. Small fish and crustaceans, drawn to this mysterious light in the darkness, like moths to flame, swim closer to investigate. When they get close enough, the anglerfish strikes with incredible speed, its jaws opening to swallow prey nearly as large as itself. The anglerfish's mouth is lined with teeth that angle inward once something enters. There's no escape, a trap that closes only one way. But here's where the anglerfish story becomes truly strange. Male anglerfish are tiny, often less than an inch long compared to females that can reach 3 feet. Imagine a house cat next to a Great Dane. When a male finds a female in the vast darkness, he bites into her skin and releases an enzyme that dissolves the tissues of his mouth and her body, fusing them together permanently like biological welding. His circulatory system merges with hers, and he becomes essentially a parasitic appendage, existing only to provide sperm when she's ready to reproduce. Scientists have found females carrying up to 8 males on their bodies, a bizarre solution to finding mates in the enormous, empty deep, where encountering another of your species might be a once-in-a-lifetime event. The deep sea contains underwater lakes and rivers, pools of super-salty brine that are denser than the surrounding seawater. These pools sit in depressions on the seafloor, complete with distinct shorelines where normal seawater meets the brine beaches in the abyss. The density difference is so extreme that submarines can actually float on the surface of these brine pools like boats on a lake. But these aren't places of life. They're toxic to most creatures, killing zones on the ocean floor. The high salinity and often high concentrations of methane or hydrogen sulfide make them deadly. Yet even here, specialized bacteria thrive at the edges, forming microbial mats that feast on chemicals toxic to other life, proving that where there's chemistry, there's usually life. The barrel-eye fish has a transparent head, not translucent, truly transparent, like crystal clear glass, like looking through a window. Inside this see-through dome, you can watch its tubular eyes rotating as the fish looks around. Biological machinery, visible and operating. These bizarre eyes point upward, searching for the silhouettes of prey against the faint light from above, always watching the ceiling of their world. For decades, scientists couldn't understand how this fish could see forward to eat, since its eyes seemed permanently fixed looking up. Then, researchers discovered the fish can rotate its eyes forward inside its transparent head, like turrets in a glass dome, pivoting to face whatever direction they need. The green glow in its eyes isn't from bioluminescence, but from a yellow pigment that filters out sunlight, helping it spot bioluminescent prey more clearly. 70% of life in the deep sea relies on marine snow, that constant, gentle rainfall of dead organisms, fecal matter, and organic debris drifting down from the sunlit surface. This may sound unpleasant, but it's the foundation of deep-sea ecosystems, the base of a food chain in a place where no plants can grow, where photosynthesis is impossible. Marine snow falls at different rates, depending on size and compositions. Small particles may take weeks to reach the seafloor, drifting like actual snowflakes, while larger chunks, like dead whales, sink relatively quickly. Some particles are eaten and re-excreted dozens of times during their descent, supporting community after community at different depths, a meal recycled through the water column. The deep sea is the world's largest graveyard. When whales die near the surface, their massive bodies sink to the seafloor, creating what scientists call whale falls, bonanzas, in the desert of the deep. A single whale carcass can support a complex ecosystem for decades, for 50 to 75 years. First come the mobile scavenger sleeper sharks, hagfish, and crabs stripping away soft tissue in a feeding frenzy that might last a year, a rush hour in slow motion. Then bone-eating worms called osedacs, which look like pink flowers blooming from death, colonize the skeleton, using acid to dissolve the bone and access the lipids inside. Finally, bacteria break down the remaining nutrients, an oasis of abundance in the desert of the deep, all from a single death. Goblin sharks look like they've swum straight out of prehistoric nightmares, with their elongated flat snouts and protrusible jaws that can shoot forward like alien mouthparts. They're sometimes called living fossils, virtually unchanged for 125 million years they knew the dinosaurs. They're rare, living at depths of around 4,000 feet, and are occasionally caught by accident in deep-sea fishing nets, surprises from the abyss. When they attack prey, their jaws extend forward, dramatically sometimes projecting several inches beyond their snout, before snapping back with their catch. The species is pink-tinged in life due to visible blood vessels beneath translucent skin, adding to their otherworldly appearance, ghosts with teeth. The ocean's midnight zone begins at 3,300 feet deep, where absolutely no sunlight penetrates, where the last photon from the surface gives up and fades away. Yet this zone, along with the deeper abyssal and hadal zones, makes up 95% of the livable space on Earth. We often think of rainforests or savannas when we picture biodiversity, but the greatest amount of living space on our planet exists in eternal darkness, under crushing pressure, in near-freezing temperatures. This is where the majority of Earth's habitat actually is a cold, dark, high-pressure realm we've barely begun to understand, a world larger than all continents combined. Dumbo octopuses live at depths of up to 13,000 feet, making them the deepest living octopuses known to science, deeper than the Grand Canyon is deep. They're named for their ear-like fins that flap to propel them through the water, looking remarkably like Disney's flying elephant if it lived in eternal night. Unlike most octopuses, which crawl along the seafloor or swim in short bursts, Dumbo octopuses spend their lives hovering above the ocean floor, gently flapping through the darkness like living kites. They're small, usually under 12 inches long, and feed on snails, worms, and crustaceans they find on the seafloor. There are at least 15 species of Dumbo octopuses, and scientists suspect there may be many more we haven't discovered yet. Variations on a theme of adorable Dea deep sea is home to zombie worms, the Osedax we mentioned earlier. These worms have no mouth, no stomach, and no digestive system as we understand it. Creatures that shouldn't be able to eat, yet somehow do. Instead, they have root-like structures that penetrate bone-like living drills, and inside these roots live symbiotic bacteria that digest the bone's nutrients and share them with the worm. The worms themselves are female. Males are microscopic and live inside the female's tubes, thousands of them in a single female, reduced to little more than sperm-producing sacs. It's a partnership so strange it seems designed by alien architects, biology that reads like science fiction. Dragonfish are only 6 inches long, but are apex predators of the deep sea, proof that size isn't everything in the dark. They have teeth so large they can't close their mouths. Their fangs protrude even when their jaws are shut, giving them a permanent nightmare grimace. But here's the truly remarkable adaptation. Dragonfish produce red bioluminescence, something almost unique in the deep sea, a color nearly invisible to other creatures. Most deep-sea creatures can't see red light. They've evolved to see only blue and green wavelengths because that's what most bioluminescence produces. The dragonfish essentially has night vision goggles, illuminating prey with a searchlight the prey cannot see. Hunting with invisible light, a predator with a secret weapon. The deep sea has its own weather system. Scientists have discovered benthic storms, powerful currents that sweep across the deep ocean floor, sometimes lasting for months, underwater hurricanes in slow motion. These storms don't involve wind or rain, of course, but they create turbulent conditions on the seafloor, stirring up sediment, moving nutrients, and affecting the creatures that live there. During these events, bottom-dwelling creatures must cope with increased current speeds and reduced visibility from suspended sediment, much like terrestrial animals weather a sandstorm, proving that even in the stillness of the abyss, change comes. Gulper eels look like swimming mouths, also called pelican eels. They have enormous jaws that can open wide enough to swallow prey larger than themselves, mouths that seem disproportionate to any reasonable body plan. Their bodies are thin and whip-like, sometimes reaching 6 feet in length, but most of that length is tail, stretched out behind like a living ribbon. The massive mouth isn't particularly useful for catching fast-moving prey. Instead, gulper eels likely swim with their mouths open like living nets, straining water for small crustaceans and fish. At the end of their tails, they have a light-producing organ, possibly used as a lure or for communication, a lantern in the darkness. The deep sea is Earth's largest museum of undiscovered species. Scientists estimate that 91% of ocean species remain undescribed, unknown to science, unnamed by humans. Every deep-sea expedition discovers new species, sometimes dozens of them on a single dive, sometimes in a single scoop of sediment. In 2020, researchers exploring the Clarion-Clipperton Zone in the Pacific Ocean collected specimens from an area about the size of a basketball court and found that 48 of the 74 species they collected were completely new to science. Imagine that rate of discovery across the entire deep ocean, and you begin to sense how little we truly know, how much mystery remains. Grenadiers, also called rat-tails, are among the most abundant fish in the deep sea, the sparrows of the abyss. They have large heads, tapering bodies, and long rat-like tails, hence their common name, resembling rodents that somehow learned to swim. Some species are quite large, reaching over 3 feet in length, and they're active predators and scavengers, constantly searching the seafloor for food. Their swim bladders, gas-filled organs that help fish control their buoyancy, are adapted for deep-sea life. When grenadiers are brought to the surface too quickly, the rapid pressure change causes these swim bladders to expand catastrophically, often pushing out through their mouths like biological balloons. It's a grim reminder that these creatures are built for a world completely different from ours, incompatible with our realm. The deep sea has volcanoes that nobody has ever seen erupt. Scientists know they exist because we've found recently cooled lava flows on the seafloor and measured increased temperatures in the water column, suggesting recent eruptions, evidence of fire in the deep. But the deep ocean is so vast and so difficult to monitor that we've never actually witnessed a deep-sea volcanic eruption in real time. These underwater volcanoes create new seafloor, spewing molten rock that cools instantly in the frigid water, forming bizarre rock formations called pillow basalt. The violence and beauty of creation happening in total darkness, unobserved, uncelebrated. Fangtooth fish have the largest teeth relative to body size of any fish in the ocean. Their fangs are so enormous that they can't fit inside their mouth. Instead, the lower fangs slot into special sockets in the roof of the mouth, penetrating into the skull, like evolutionary design flaws that somehow work perfectly, despite their terrifying appearance. Fangtooth fish are only about 6 inches long, all ferocity packed into a tiny, nightmarish package. They live at depths of 16,000 feet in absolute darkness, and their enormous eyes help them detect even the faintest bioluminescent glow. Young fangtooth fish look nothing like adults. They're light-colored with long spines and live in shallower water, migrating to the depths only as they mature, descending into darkness as they age. The deep ocean floor is covered with trackways and burrows, evidence that complex communities exist even in the Hadal Zone, the ocean's deepest trenches. Cameras lowered to these extreme depths have captured images of burrow systems, spiral tracks, and various mysterious patterns in the sediment, writing in mud. Scientists still don't know what creatures create many of these markings. The seafloor at these depths looks like an alien landscape, rippled and marked with the signatures of invisible life, a written language we're still learning to read, poetry in sediment. Snailfish hold the record for the deepest living fish ever filmed. In 2017, scientists captured footage of a snailfish swimming at a depth of 26,200 feet in the Mariana Trench, nearly 5 miles down, deeper than most of the ocean. The pressure at this depth is over 1,000 times greater than at the surface. Pressure that would turn a human into something unrecognizable. These fish have gelatinous, scaleless bodies and seem to glide more than swim. Ghostly, pale apparitions in the camera lights. Scientists believe there's a depth limit beyond which fish cannot exist, perhaps around 27,000 feet, because the chemicals that make up their cells begin to malfunction under such extreme pressure, a biological absolute limit. The deep sea glows with bioluminescence, even when no creatures are present. Scientists have discovered that some deep-sea sediments themselves emit light, likely due to bioluminescent bacteria living in the mud, galaxies underfoot. So even the ocean floor glows, a carpet of cold starlight in the abyss. When deep-sea submersibles stir up this sediment, clouds of light swirl around them, constellations of bacteria disturbed from their rest, creating an underwater aurora, beauty in disturbance. Cookie-cutter sharks are barely 2 feet long, but leave their mark on animals hundreds of times their size. They have specialized lips that work like suction cups, allowing them to attach to whales, dolphins, sharks, and even submarines, parasites, with precision. Once attached, they bite down with their razor-sharp teeth and spin their bodies, carving out a perfectly circular plug of flesh like biological hole saws. The wound they leave looks exactly like it was made with a cookie cutter, hence the name, an injury so distinctive it identifies the culprit. Large marine animals often bear multiple cookie-cutter shark scars, round divots in their skin, medals from encounters in the deep. Nuclear submarines have been damaged by cookie-cutter sharks attacking their rubber sonar domes. The sharks apparently mistaking the subs for large prey, military equipment defeated by a 2-foot fish. The deep sea is incredibly energy-poor compared to surface environments. Sunlight provides abundant energy to terrestrial and shallow marine ecosystems. But the deep depends entirely on the meager rain of marine snow and occasional large foodfalls, scraps from above. As a result, deep-sea creatures have evolved extremely efficient metabolisms. Some can survive for months without eating, their bodies running on minimal energy, hearts beating slowly in the cold darkness. Time moves differently down there. Life proceeds at a glacial pace, each meal a precious windfall to be conserved, existence on a tight budget. Glass sponges have skeletons made of silica, essentially glass. These creatures, which can live for thousands of years, build intricate lattice structures more beautiful than any cathedral, architecture without architects. Some glass sponges stand over 6 feet tall, ancient monuments on the deep seafloor, older than nations. They're filter feeders, passing water through their bodies to extract microscopic food particles, and they do this so efficiently that a single large sponge can filter thousands of gallons of water per day. Their glass skeletons are incredibly strong, with a structural efficiency that human engineers study for inspiration in building design, learning from organisms that perfected their craft millions of years ago. The twilight zone of the ocean, between 600 and 3,000 feet, contains more fish biomass than all other ocean zones combined. This layer of life, called the deep scattering layer, was actually discovered by accident during World War II. Naval sonar operators detected what appeared to be a false seafloor that rose at night and sank during the day, a mysterious echo. They eventually realized they were detecting dense schools of fish and other creatures that migrate vertically every day, rising toward the surface at night to feed, then descending back to the depths at dawn to avoid predators. This is the largest migration of animals on Earth, happening every single day, involving billions upon billions of creatures. Rush hour in the ocean. Sea pigs are actually sea cucumbers that live on the deep ocean floor, particularly in the abyssal plains. They look like bloated pink pigs with tube feet, waddling across the muddy seafloor in herds. Farm animals of the abyss. These strange creatures feed on organic particles they extract from the mud, essentially eating their way across the ocean bottom, processing sediment for nutrition. Scientists aren't entirely sure how they find food-rich areas, but evidence suggests they can detect chemical trails in the water and follow them to good feeding grounds. During certain seasons, huge aggregations of sea pigs gather in particular areas. Though we don't fully understand why, conventions of the strange, the deep sea is home to some of the longest living creatures on Earth. Greenland sharks, which frequent deep, cold waters, can live for over 400 years. A Greenland shark, alive today, might have been born before Galileo pointed his telescope at the stars, before Shakespeare wrote his final play. These sharks grow incredibly slowly, perhaps less than half an inch per year, and don't reach sexual maturity until they're around 150 years old. They spend more than a human lifetime just growing up. They're sluggish hunters, swimming slowly through frigid waters at speeds barely faster than drifting. Yet, they've been found with seal parts in their stomachs. Scientists still debate whether they actively hunt seals or primarily scavenge carcasses that sink from the ice above, the mystery of the patient predator. Deep-sea corals exist in complete darkness, thriving without sunlight at depths of over 6,000 feet. Unlike their shallow water cousins that depend on photosynthetic algae for food, deep-sea corals are pure predators, extending their polyps to catch passing plankton and marine snow, hunters rooted in place. Some of these corals are incredibly old. Certain species grow less than 1/10 of an inch per year, meaning large colonies can be thousands of years old. The oldest known deep-sea coral was estimated to be over 4,000 years old. It was a sapling. When humans were building the pyramids, when woolly mammoths still walked the earth, chimeras, also called ghost sharks or ratfish, split from other fish lineages over 400 million years ago. They have smooth, scaleless skin and large eyes adapted for low light windows to a dark world. Male chimeras have a retractable sex organ on their foreheads. Yes, their foreheads. With a club-like tip covered in spines. Scientists aren't entirely certain how they use this bizarre appendage for mating, adding yet another mystery to these ancient creatures. Chimeras feed by crushing hard-shelled prey with their plate-like teeth, searching the deep seafloor for mollusks and crustaceans, grinding meals in the darkness. The deep ocean contains more gold than has ever been mined by humans. Seawater contains dissolved gold, not much, about 13 billionths of a gram per liter, but the ocean contains a lot of water, 1.3 billion cubic kilometers. Scientists estimate there are about 20 million tons of gold dissolved in Earth's oceans. The challenge, of course, is extracting it. The concentration is so low that no economically viable method exists to harvest this treasure. So there it remains, an invisible fortune dissolved in the cold, dark depths. More wealth in gold than in all the banks and vaults combined. Untouchable, a treasure that will likely remain forever out of reach. Hydrothermal vents create oases of life in the deep sea. These underwater hot springs occur where seawater seeps into cracks in the seafloor, gets heated by magma below, and then erupts back out at temperatures exceeding 700 degrees Fahrenheit, hot enough to melt lead. The superheated mineral-rich water supports entire ecosystems based not on photosynthesis, but on chemosynthesis bacteria that derive energy from chemicals, like hydrogen sulfide, poison transformed into food. These bacteria form the base of a food chain that includes giant tube worms, white crabs, eyeless shrimp, and numerous other bizarre species found nowhere else on Earth. Communities built on chemistry. Giant tube worms living at hydrothermal vents can grow over 8 feet long, but they have no mouth, no stomach, and no way to eat. Instead, they have a specialized organ called a trophosome that houses billions of symbiotic bacteria, an internal farm. The worms absorb hydrogen sulfide, oxygen, and carbon dioxide from the water through their bright red plumes, transport these chemicals to the bacteria living inside them, and the bacteria convert these raw materials into nutrients the worm can use. It's a partnership so intimate that neither organism can survive without the other. A merger between two forms of life, proof that survival sometimes means giving up independence. Soft pause, a breath in the darkness. We've traveled far now, haven't we? From the sunlit surface down through the twilight, past the midnight zone, touching the edges of the abyss. We've met creatures that glow, creatures that merge, creatures older than human civilization. Each one a solution to the challenge of surviving in Earth's most extreme environment. But there's more wonder waiting in the deep, more mysteries to unfold, more beauty hiding in the darkness. Rest here for a moment, suspended in the twilight between zones. The deep sea contains underwater rivers of ultra-cold, ultra-dense water that flow along the ocean floor for thousands of miles. These thermaline currents move slowly, perhaps only a few miles per year, but they transport enormous volumes of water, far more than all the world's rivers combined, the Mississippi and Amazon rendered insignificant by comparison. The largest of these is the Antarctic bottom water, which flows northward from Antarctica, carrying oxygen to the deep ocean. Without these currents, the deep sea would be anoxic, devoid of oxygen, unable to support the life it does. These rivers in eternal darkness keep the deep sea breathing, circulation in slow motion. Vampire squids can turn themselves inside out. When threatened, they pull their 8 arms up and over their body, inverting their web to expose the fleshy spines underneath, a transformation in seconds. In this configuration, they look less like a tasty morsel and more like an unappetizing, spiky blob. They can hold this defensive posture for several minutes, drifting like a piece of debris, playing dead while very much alive. It's a magic trick performed in darkness, a transformation from vulnerable creature to something predators think twice about eating, survival through shapeshifting. The deep sea contains mountains taller than any on land, we just can't see them. The mid-ocean ridge system, where new oceanic crust forms, stretches for 40,000 miles along the ocean floor, and includes peaks over 13,000 feet tall, taller than many of the Rocky Mountains. If you drained the ocean, this would be the most dramatic mountain range on Earth's surface, a spine of mountains circling the planet like seams on a baseball. These mountains are sites of constant geological activity, with volcanic eruptions and earthquakes occurring regularly, reshaping the seafloor in ways we rarely observe, creation in darkness. 6 gill sharks are living fossils, virtually unchanged for 150 million years. They swam in Jurassic seas alongside marine reptiles, and they swim today in the deep ocean. Patient survivors of countless extinction events that wiped out countless other species. These large sharks, sometimes reaching lengths of 16 feet, have 6 gill slits instead of the 5 that most modern sharks possess, an ancient feature retained. They typically inhabit depths of 600 to 6,000 feet, but occasionally venture into shallower water at night to hunt. Their eyes glow green in light, an eerie reflection that has startled more than one deep-sea camera operator. Ghost lights in the abyss. The ocean's deepest point is so remote that only 4 humans have ever reached it. The Challenger Deep, the deepest part of the Mariana Trench, lies 36,200 feet below the surface, deeper than Everest is tall, deeper than commercial airplanes fly. Film director James Cameron made a solo dive there in 2012, and before him, only 2 people had visited in 1960. In 2019, Victor Vescovo became the 4th person to reach the bottom. At that depth, even the most specialized submersibles are at their absolute limits. The pressure is so intense that it would compress a wooden ship to the density of stone. Yet, even there, even at Earth's deepest point, researchers found life amphipods, shrimp-like creatures, living in a place we once thought impossible for life to exist. Hagfish are so primitive, they don't even have jaws. These eel-like scavengers feed by burrowing into dead animals on the seafloor, eating them from the inside out, nature's cleanup crew. But their most famous trait is their slime when threatened. A hagfish can produce up to 5 gallons of thick, sticky, expanding slime in seconds, enough to fill a large bucket. This slime clogs the gills of predators, forcing them to release the hagfish, choking on goo. It's one of the most effective defense mechanisms in nature, and scientists are studying hagfish slime because its protein fibers are stronger than spider silk and could have revolutionary applications in materials science, learning from ancient evolution. The Clarion-Clipperton Zone in the Pacific Ocean contains more rare earth metals than all land reserves combined. This abyssal plain, about the size of the continental United States, is carpeted with potato-sized rocks called polymetallic nodules, rich in manganese, nickel, cobalt, and rare earth elements crucial for electronics and green technology. Mining companies are eyeing this region, but scientists warn that deep-sea mining could devastate ecosystems we barely understand. Species that evolved over millions of years in these stable environments might go extinct before we even discover them. Entire branches of life's tree eliminated for rocks to make smartphones, progress destroying mystery. Sea spiders in Antarctic waters grow to absurd sizes, a phenomenon called polar gigantism. While tropical sea spiders might have a leg span of half an inch, Antarctic species can span over a foot, 24 times larger. These bizarre arthropods, not actually spiders, but in their own strange category, have tiny bodies, with most of their organs extending into their long legs, anatomy turned inside out. Their hearts are so weak they rely on gut peristalsis to help pump blood, and some species breathe through their legs. They move across the seafloor in slow motion, like ambulatory nightmares, picking up soft-bodied prey with specialized appendages, aliens that never needed a spaceship. The deep ocean is getting louder. Industrial noise from ships, sonar, seismic surveys, and underwater construction has dramatically increased ocean noise pollution over the past century. Sound travels farther in water than in air, and low-frequency noises from ships can travel across entire ocean basins, crossing thousands of miles. Many deep-sea creatures use sound for navigation, communication, and hunting, and scientists are concerned that this acoustic smog is disrupting their behaviors in ways we don't yet understand. The deep, once imagined as a realm of perfect silence, now reverberates with the sounds of a world they've never seen, invaded by noise from above. Siphonophores are colonies of individual organisms working together to form what appears to be a single creature. The longest known siphonophore, discovered off the coast of Australia in 2020, measured over 150 feet long, longer than a blue whale, potentially the longest animal ever discovered. These gelatinous creatures drift through the water column like living lace, each polyp in the colony specialized for a specific function: feeding, reproduction, swimming, or defense. They're essentially underwater collective organisms, proof that individuality is more complicated than we often assume, many becoming one. The deep sea contains lakes of liquid carbon dioxide. In certain areas where CO2 seeps from the seafloor, it accumulates in depressions at depths where the pressure and temperature keep it in liquid form, pools of poison on the ocean floor. These CO2 lakes are toxic to most marine life, but as always, specialized organisms have adapted to thrive at their edges. Scientists study these areas to better understand what might happen as oceans absorb more carbon dioxide from the atmosphere. A preview of possible futures, laboratories of change. Luminescent fish in the deep sea don't just produce light. Many have specialized light organs with lenses, reflectors, and color filters, like living flashlights engineered by evolution. Some species can even control the color of their light by adjusting the chemistry of their bioluminescence or by passing the light through different colored filters. Stoplight lucigos, for instance, can produce red light in a world where almost nothing else can, giving them a huge predatory advantage. Their light organs are marvels of biological engineering, more sophisticated than some human-designed optical devices, precision instruments in fish form. The deep sea recycles everything. The phrase in nature, "there is no waste," is truest in the deep ocean, where resources are so scarce that every scrap of organic matter is used and reused. Bacteria break down everything that larger scavengers leave behind, and those bacteria become food for filter feeders, which in turn become food for predators. Even the slime secreted by hagfish doesn't go to waste. Bacteria consume it, converting it back into nutrients that eventually become marine snow, continuing the cycle. It's a closed-loop system refined over hundreds of millions of years. A lesson in efficiency we're still learning. Zero waste perfected. Deep-sea jellyfish can be enormous. The lion's mane jellyfish, which occurs in deep, cold waters, can have tentacles over 120 feet long, longer than a blue whale, longer than 3 school buses parked end to end. These tentacles trail behind the bell like deadly streamers, armed with millions of stinging cells. Most of the time, the jellyfish drifts with currents, its tentacles forming a vast trap for any small creature that brushes against them. In the darkness of the deep sea, prey can't see the tentacles until it's too late, already tangled in toxic threads, already being pulled toward the jellyfish's feeding arms, caught in invisible nets. The deep ocean's food chains are incredibly efficient compared to terrestrial ecosystems. On land, only about 10% of energy passes from one trophic level to the next. 90% is lost as heat and waste. But in some deep-sea ecosystems, this efficiency is higher because creatures move slowly, have slow metabolisms, and waste very little energy. Some deep-sea fish have muscle tissue that's gelatinous and watery rather than firm, reducing the energy needed to maintain it. They're living on an extremely tight energy budget, optimized through millions of years to survive in conditions of near starvation, efficiency through necessity. Deep-sea octopuses brood their eggs longer than any other animal known to science. One species, observed by researchers in Monterey Bay, was seen guarding her eggs for 4.5 years, 1,581 days. During this entire time, she never left them, not even to feed. She slowly starved to death while protecting her developing young, waving water over the eggs to keep them clean and oxygenated. When the baby octopuses finally hatched and swam away, their mother died shortly after, having given everything for the next generation. It's a devotion almost impossible to comprehend, a maternal sacrifice played out in darkness. Witnessed by no one except a few fortunate scientists, love measured in years of starvation. Zombie worms, those Ozidacs we've mentioned, were only discovered in 2002, despite having existed for millions of years. Scientists found them covering the bones of a gray whale carcass that had sunk to the seafloor near Monterey Bay. Before this discovery, researchers couldn't understand how whale bones on the ancient seafloor were broken down so completely. Now we know these strange worms, with their root systems that bore into bone like living drills, have been the ocean's bone recyclers for eons. They've likely been doing this work since whales first evolved, perhaps over 30 million years. Invisible engineers of the deep's recycling system, discovered only when we finally looked closely enough. The deep ocean has mountains of trash. The Mariana Trench, Earth's deepest place, contains plastic bags, beer bottles, and candy wrappers captured on camera by deep-sea explorers. No place on Earth remains untouched by human activity. Even at 36,000 feet deeper than Everest is tall. In a place only for people have ever visited, our waste has arrived first. Scientists found plastic fibers in the tissues of amphipods living in the tidal zone. Proof that our pollution has infiltrated the food chain even in the most remote ecosystem on the planet. It's a sobering reminder that distance doesn't equal protection, that the deep sea, for all its vastness, is still part of our world, connected to our actions. Comb jellies, or ctenophores, create rainbow light as they swim. They're not bioluminescents. They have rows of hair-like cilia that beat in waves to propel them through the water. When light hits these beating cilia, it diffracts into rainbow colors that shimmer and flow along their bodies like liquid prisms, like living auroras. In the deep sea, where research lights illuminate them, comb jellies become moving rainbows in the darkness, proof that beauty exists even where no one is meant to see it. These creatures have existed for over 500 million years, creating their rainbow displays in darkness for eons before human eyes ever witnessed them, artists without an audience. The deep sea contains more minerals than all land-based mines combined. The seafloor is scattered with valuable resources, manganese nodules, cobalt-rich crusts, massive sulfide deposits around hydrothermal vents, Some estimates suggest the Pacific Ocean floor alone contains more rare earth elements than all known land reserves. But extracting these resources would require massive disruption to ecosystems we barely understand. Every time a mining machine scrapes the seafloor, it would destroy habitat that took millions of years to develop, eliminating species before we even know they exist. The wealth is there, glittering in the darkness, but the cost of taking it might be immeasurable. Treasure with a terrible price. Lanternfish are the most abundant vertebrates on Earth by sheer numbers. These small, bioluminescent fish, usually just a few inches long, exist in such enormous quantities that they make up over half of all deep-sea fish biomass. Billions upon billions of individuals. Billions upon billions of lanternfish participate in the daily vertical migration, rising toward the surface each night to feed and descending back to depth each dawn. During World War II, naval sonar operators initially thought their sonar had malfunctioned when it detected the deep scattering layer. They couldn't believe a biological phenomenon could create such a massive, solid-looking return signal. But it was real. The largest migration on Earth, performed by fish most people have never heard of. Anonymous abundance. The deep ocean has rivers of hot water flowing from hydrothermal vents. These streams of superheated, mineral-laden water can reach temperatures of 750 degrees Fahrenheit, hot enough to melt lead, hot enough to boil water instantly at the surface, yet they're surrounded by near-freezing seawater just inches away. The temperature gradients are so extreme that you could theoretically freeze and boil simultaneously if you straddled the boundary. Creatures living at hydrothermal vents must navigate these extreme temperature zones carefully, clustering in areas where the vent water has mixed enough with seawater to become tolerable. Its climate zones, compressed into inches, tropical and Arctic, separated by less space than the width of your hand. Extremes meeting. Sea angels are pteropods swimming, sea snails that have lost their shells and evolved wing-like appendages. They fly through the water with graceful, flapping motions, their translucent bodies glowing faintly in bioluminescent displays. Underwater fairies. Despite their angelic appearance and name, they're voracious predators of other pteropods called sea butterflies. When a sea angel catches a sea butterfly, it uses specialized hooks to extract the prey from its shell, consuming it completely. Its violence performed with ballet-like grace, predation that looks like a dance, proof that beauty and brutality often swim together in the deep aesthetics, divorced from morality. The deep sea is getting warmer, and creatures there have nowhere to go. In surface oceans, when water temperatures rise, mobile species can migrate toward the poles or into deeper water to find their preferred temperature. But deep-sea creatures are already in the coldest water available. They've evolved over millions of years in a stable, cold environment, and many cannot tolerate even slight temperature increases. As the deep ocean slowly warms due to climate change, these creatures face a crisis: adapt impossibly quickly or disappear. Some species that have existed unchanged for millions of years may vanish within our lifetimes. Casualties of changes happening too fast for evolution to compensate, victims of our atmosphere. Dumbo octopuses, those adorable, ear-flapping cephalopods, swallow their prey whole. Unlike octopuses that use their beaks to bite and tear food, Dumbo octopuses engulf small worms and crustaceans entirely, using their webbed arms like a net to capture prey and push it directly into their mouths. They have relatively small beaks because they don't need to process their food. It simply disappears into them whole, swallowed in one gulp. Watching footage of a Dumbo octopus feeding is strangely hypnotic. This cute creature suddenly opening like a parachute to envelop its meal. Gentleness concealing ruthless efficiency, adorable predation. The deep ocean contains underwater waterfalls of sand in submarine canyons, especially off the coasts of continents. Sand and sediment pour down underwater slopes in dense currents, creating cascades that can persist for hours or even days. These underwater avalanches carve the canyons deeper over time, transporting massive amounts of sediment from shallow to deep water. Some submarine canyons rival the Grand Canyon in scale, and they're constantly being reshaped by these flows of sand and mud. Landscapes in perpetual slow motion, transformation, geology in action unseen. Deep-sea dragonfish have photophores light producing organs arranged along their bodies like portholes on a ship. Some species have dozens of these light organs, each one capable of producing light independently. Scientists believe dragonfish can control these lights individually, creating patterns and sequences for communication or hunting. Imagine Morse code written in bioluminescence, conversations happening in flashes of light in the absolute darkness. A language we're only beginning to notice exists, messages sent and received between creatures we rarely see, communication in code. The deep sea has seasons, but they're not like surface seasons. Instead of temperature-driven changes, deep-sea seasons are driven by food availability. When spring blooms of phytoplankton die off at the surface, their remains sink as an intense pulse of marine snow, arriving at the deep seafloor weeks or months later. Deep-sea creatures have evolved to anticipate these pulses, timing their reproduction and other energy-intensive activities to coincide with the arrival of seasonal food. It's a calendar written in falling debris, spring arriving as a rain of death from above. Winter, when the rain slows to a trickle, seasons inverted. Sleeper sharks are some of the largest predators in polar deep waters. Pacific sleeper sharks can exceed 20 feet in length, and they hunt by moving incredibly slowly, so slowly that their prey don't perceive them as threats until it's too late. Their metabolism is adapted for cold water, meaning they need very little food to survive despite their enormous size. Scientists have found seal parts, fish, squid, and even other sharks in their stomachs, though how these lethargic giants catch such fast-moving prey remains mysterious. Perhaps their hunting strategy is simply to be so slow, so patient, that they become part of the landscape, invisible through sheer stillness, camouflaged by lethargy. The ocean floor has fields of glass. When volcanoes erupt underwater, the lava can cool so rapidly that it forms volcanic glass called obsidian or hyaloclastite. In some areas, the seafloor is covered with this shattered glass, creating landscapes that would slice through equipment and any creature that wasn't adapted to it. Yet life persists even here, with specialized bacteria colonizing the glass surfaces and creatures carefully navigating the sharp terrain. Nature finds a way, even in its own broken fragments, life unshattered mirrors. Deep-sea hatchetfish have upward-pointing eyes and bioluminescent organs on their undersides. This combination serves a clever purpose. Their eyes watch for the silhouettes of prey above them, backlit by faint surface light, while their belly lights create counter-illumination that makes them invisible from below. They adjust the intensity of their bioluminescence to match the light coming from above, essentially erasing their own shadow. To a predator looking up from deeper water, a hatchetfish simply disappears. Camouflaged against the sky it can never reach, a master of invisibility in a world of hunters, hiding with light. The deep sea is the most stable environment on Earth. Temperature, salinity, and light levels, or lack thereof, the deep sea remain essentially constant over years, decades, even centuries. This stability has allowed some species to exist virtually unchanged for millions of years. They've achieved a kind of evolutionary equilibrium where there's no pressure to change because their environment never changes. They're perfect solutions to an unchanging problem. Organisms that found their form millions of years ago and saw no reason to alter it. In a sense, they've transcended evolution by completing it, finished products in a finished world. Siphonophores hunt with stinging tentacles that can extend over 100 feet from their bodies. These tentacles drift through the water like invisible fishing lines, armed with millions of nematocystis explosive cells that fire harpoon-like structures into any creature that touches them. A small fish brushing against a siphonophore tentacle is instantly paralyzed and gradually reeled in toward the feeding polyps. The siphonophore never moves, never searches. It simply drifts, trailing deadly nets through the darkness, waiting for the ocean currents to bring food to it. Patience as strategy. The deep sea contains fossil graveyards. In certain areas, the sea floor is littered with fossils of ancient marine creature shells of ammonites, teeth of prehistoric sharks, bones of extinct marine reptiles. These fossils have lain undisturbed for millions of years, preserved in the cold, oxygen-poor conditions of the deep. Walking across these fossil fields would be like walking through time, stepping on creatures that swam in Jurassic seas. Physical evidence of deep time spread across the seafloor like an outdoor museum no one visits. History underfoot. Barrel fish can see through their own heads. We mentioned earlier that their eyes rotate inside transparent domes. But what makes this even stranger is that their actual eyes, the tubular structures, point upward through the top of their heads. The dark spots that look like eyes on the front of their faces are actually their nostrils. So when you look at a barrel fish, you're looking at a creature whose brain is visible, whose eyes point up through a transparent skull, and whose face is essentially an illusion. It's biology as surrealism, anatomy that seems deliberately designed to confuse, nature playing tricks. The deep ocean has worms that glow red. Most bioluminescence in the ocean is blue or green because those wavelengths travel farthest in water. But some deep-sea worms produce red bioluminescence, which most deep-sea creatures cannot see. Scientists speculate these worms might use red light for private communication signals, visible only to others of their species, invisible to predators. It's like having a secret language, conversations in a color channel that only you can perceive, whispering in red light while everyone else is deaf to that frequency. Private broadcasts in public space. Deep-sea mining has already begun in some areas, despite scientific warnings. Companies have started testing equipment that scrapes the seafloor to collect mineral-rich nodules, and full-scale commercial operations may begin within years. These machines are essentially underwater bulldozers, scraping away the top layer of sediment and everything living in it. The sediment clouds they create can drift for miles, smothering creatures far from the mining site. Species that took millions of years to evolve could go extinct before we even know they exist. Ecosystems destroyed for minerals that could potentially be recycled from existing human waste. We're strip mining the deep before we've even finished exploring it, destroying before discovering. A gentle pause, floating in the vastness. You are here with me, suspended in imagination between the midnight zone and the abyss. We've witnessed creatures that defy logic, adaptations that seem impossible, beauty in the most unexpected places. The deep sea is teaching us that life is more creative, more resilient, more surprising than we ever imagined. But our journey isn't complete. One more descent awaits into the Hadal Zone, the very deepest trenches, and then back up toward the light, carrying these mysteries with us. Anglerfish have evolved at least 18 different families, each with unique variations on the Laurendambush strategy. Some have bioluminescent lures, others have lures that mimic small prey animals. Some have multiple lures, like underwater chandeliers. Some are tiny, others grow to over 3 feet long. Despite their diversity, all share the parasitic male reproductive strategy. Males are always much smaller than females, and often fuse to them permanently. It's a body plan so successful, it's been repeated and modified across dozens of species. Proof that in the deep sea's eternal darkness, sitting still and letting prey come to you is an excellent survival strategy. Variations on a successful theme. The deep ocean contains brine falls underwater, waterfalls made of super salty water. We mentioned brine pools earlier, but where these pools overflow, or where brine seeps from the seafloor, it flows downhill like a dense liquid, creating waterfalls and rivers of brine that carve channels in the sediment. These brine flows are toxic to most life, but they're also beautiful in a haunting way. Invisible rivers flowing through an invisible sea, detectable only by how they refract light or by the dead and dying creatures at their edges. Beauty in toxicity. Cookie-cutter sharks have possibly the strongest bite force relative to body size of any shark. These small sharks, less than 2 feet long, can generate tremendous pressure with their suction cup lips and rotating bite, enough to remove chunks of flesh from whales, dolphins, and even nuclear submarines. Their teeth are arranged in a continuous cutting surface, like a hole saw, and they're constantly replaced. A cookie-cutter shark might go through thousands of teeth in its lifetime. Their precision tools, wrapped in shark form, evolved for a very specific job that they perform with unsettling excellence. Specialists of the circular wound. The deep sea is home to animals that never stop growing. While most creatures reach a maximum size and then maintain it, some deep-sea species exhibit indeterminate growth. They continue growing throughout their lives, limited only by food availability and lifespan. This is why we occasionally find truly enormous individuals of certain species, ancient survivors that have been eating and growing for decades or even centuries. The largest specimens of many deep-sea species are likely the oldest, having accumulated size over lifespans we can barely measure. Giants of the deep. Deep-sea vent communities were only discovered in 1977. Before that, scientists believed the deep sea floor was essentially a barren wasteland, too dark and food-poor to support complex life. The discovery of hydrothermal vents teeming with giant tube worms, clams, crabs, and other creatures completely revolutionized our understanding of life's possibilities. It proved that life doesn't need sunlight. Chemosynthesis works just as well as photosynthesis for supporting ecosystems. This discovery gave scientists hope that life might exist in similar environments elsewhere in the solar system, on ocean moons like Europa orbiting Jupiter or Enceladus orbiting Saturn, underwater worlds waiting to be explored. Abyssal sea cucumbers are sometimes called headless chickens because of their bizarre appearance. These red, nearly transparent cucumbers have large swimming appendages that look like wings or flaps, and they drift above the seafloor in an ungainly manner that somewhat resembles a plucked chicken trying to fly. The deep ocean is losing oxygen. As surface waters warm, they hold less dissolved oxygen, and as ocean circulation weakens, less oxygen-rich water reaches the deep. Oxygen minimum zones are expanding, squeezing creatures into narrower habitable ranges. Some areas that once supported diverse life are becoming dead zones, not through pollution, but through oxygen depletion driven by changing climate. Scientists predict that many deep-sea species will experience significant habitat loss within this century, displaced by spreading anoxia, refugees with nowhere to flee, victims of invisible change. Telescope fish have eyes on stalks that can extend from their heads. These bizarre fish, which live in the twilight zone, can extend their tubular eyes outward on short stalks, giving them better stereoscopic vision for judging distances in the dim light. When not needed, the eyes can retract back toward the head. It's an adaptation that seems almost mechanical. Eyes on adjustable mounts, biological periscopes that can be deployed or stowed as needed. The first scientists to observe this behavior weren't sure they were seeing correctly, seemed too strange to be real, too engineered to be natural. The deep sea has creatures that explode when brought to the surface. The rapid pressure change causes gas-filled organs, like swim bladders, to expand catastrophically. Some fish arrive at the surface with their stomachs pushed out through their mouths, their eyes bulging from their sockets, their bodies distorted beyond recognition. It's a grim reminder that these creatures are built for an environment so different from ours that the two are fundamentally incompatible. What's normal pressure for them would crush us. What's normal for us destroys them. Mutual incompatibility. Giant isopods are deep-sea relatives of pillbugs, except they grow to over 16 inches long and can weigh over 3 pounds. So imagine a roly-poly, the size of a small dog. These enormous crustaceans are scavengers, feeding on dead whales, fish, and squid that sink to the seafloor. They have complex mouths adapted for both scavenging soft tissue and cracking through shells. Giant isopods can survive for years without food, entering a state of near hibernation during long periods between food falls. In aquariums, they've been observed going 5 years without eating. Their metabolism slowed to an almost undetectable level, patience incarnate, hunger suspended. The deep ocean floor moves. Tectonic plates slowly spread apart at mid-ocean ridges, creating new seafloor, while old seafloor subducts beneath continental plates, descending back into the mantle. The entire ocean floor is younger than 200 million years, ancient by human standards, but young in geological time. This means the deep ocean floor is constantly being created and destroyed, a conveyor belt of rock cycling through the planet's interior. Any creature living on the abyssal plane is on a slow-motion journey toward an undersea trench where its habitat will eventually be destroyed, pulled down into the Earth's mantle, and recycled temporary homes on moving ground. Deep-sea octopuses have been observed brooding eggs for nearly 5 years, and during this time they defend their egg clusters from predators without ever leaving to feed. Researchers watched one octopus for 53 months over 4 years, guarding her eggs in the same location, gently cleaning them, waving water over them to provide oxygen. By the end, she was emaciated, barely moving, but she persisted until her eggs hatched. Then, mission accomplished, she died. It's maternal devotion on a timescale that humbles us, sacrifice measured in years, not hours or days, love as endurance. The deep sea contains underwater avalanches that dwarf any terrestrial landslide. Submarine landslides can move thousands of cubic miles of sediment in minutes, traveling hundreds of miles at speeds exceeding 60 miles per hour. The largest known submarine landslide, the Storegga Slide off the coast of Norway, moved an area the size of Iceland. It triggered a massive tsunami that struck the coasts of Scotland, Norway, and Iceland about 8,000 years ago. These events are rare, but when they occur, they reshape entire regions of the deep seafloor, obliterating everything in their path, catastrophes in slow geological time. Deep-sea shrimp living near hydrothermal vents have light-sensing organs on their backs instead of eyes. These dorsal photoreceptors can detect the faint glow of light emitted by superheated vent water. Heated water can emit dim light through black body radiation. The shrimp use these sensors to navigate around vents, staying close enough to benefit from the chemosynthetic bacteria they farm, but far enough to avoid being cooked. They're essentially navigating by sensing heat as light, a sensory ability that seems impossible but works perfectly in their extreme environment. Heat vision without eyes. The deep ocean has fish with transparent skulls and visible brains. We've mentioned barrel eyes, but there are other species with transparent or translucent heads. Scientists speculate this transparency might help reduce the fish's visibility to predators. Light passes through instead of being reflected or absorbed, making the head effectively invisible. It's camouflage through see-through anatomy, protection through transparency, evolution choosing invisibility over armor, hiding in plain sight. Deep-sea snailfish are the deepest living fish, but they're not fearsome predators. They're small, tadpole-shaped fish with gelatinous bodies and tiny teeth, feeding on small crustaceans and other invertebrates. What makes them remarkable isn't ferocity, but resilience. They survive pressures that would liquefy most organisms in complete darkness, near freezing temperatures, with minimal food. They've achieved this through special proteins that stabilize their cells under pressure and extremely efficient metabolisms. They're not conquerors of the deep, they're harmonizers with it, perfectly adapted to conditions that seem hostile to all life. Peace through adaptation. The deep ocean contains chimneys taller than redwood trees. Some hydrothermal vent structures exceed 180 feet in height, built over centuries by minerals precipitating from vent water. These chimneys are constantly growing, constantly changing, sometimes collapsing, and then rebuilding. They create three-dimensional habitat in an otherwise flat environment, providing surfaces for bacteria to colonize and nooks for creatures to shelter. Their architecture without architects, cathedrals built by chemistry, standing monuments to geological processes in the eternal night, construction through precipitation. Frilled sharks can swallow prey larger than themselves by unhinging their jaws and compressing the prey with their flexible bodies. Their needle-like teeth, all angled backward, ensure that once something is in their mouth, escape is nearly impossible, a one-way entrance. These sharks hunt by coiling their bodies and then striking like a snake, lunging forward with startling speed, considering their normally sluggish swimming. They're ambush predators in an environment where encounters are rare, making every strike count, precision in scarcity. The deep sea has worms that farm bacteria on their backs. These polychaete worms, living near hydrothermal vents, have thick coats of filamentous bacteria growing on their bodies. The worms carefully position themselves in areas where vent water mixes with seawater, providing their bacterial gardens with the perfect chemical conditions. In return, the bacteria produce nutrients the worms consume. It's agriculture without soil, farming without fields, a partnership billions of years in the making, cultivation at the cellular level. Deep-sea species are being discovered that challenge our understanding of animal classification. Some creatures found in deep waters don't fit neatly into existing taxonomic categories. They possess combinations of features that suggest they branched off from known groups millions of years ago or represent entirely new lineages. With every deep-sea expedition, we find organisms that rewrite our family trees of life, branches we didn't know existed, connections we never suspected, taxonomy in flux. The deep ocean contains hot springs of pure hydrogen. At certain vent sites, particularly in the Lost City hydrothermal field, chemical reactions between seawater and rocks produce hydrogen gas, along with methane and other compounds. Bacteria at these vents use the hydrogen as an energy source, forming the base of a food chain completely independent of photosynthesis. Scientists believe this type of chemosynthesis might have been how life first originated on Earth, and similar systems might support life on other worlds, genesis in chemistry. Gulper eels have tails that end in a glowing pink organ. The purpose of this light is still debated. Might be a lure for prey, a way to communicate with other gulper eels, or a defensive mechanism to startle predators. What's remarkable is that the light organ is separated from the main body by several feet of thin tail, like a biological fishing rod with a glowing lure at the end. The eel can wave this tail around, creating patterns of light in the darkness, though we still don't fully understand the messages it might be sending. Semaphore in the abyss. The deep ocean is the most unexplored realm on Earth. We've mapped less than 20% of the ocean floor at high resolution. Most of what we know comes from wide-scale sonar mapping that shows general features but misses details. Imagine mapping Earth's continents at such low resolution that you could see mountain ranges but not individual peaks, forests but not trees. That's the level of detail we have for most of the deep seafloor. There could be entire ecosystems, unique geological formations, even new types of geological activity that we simply haven't found yet, blank spaces on the map. Deep-sea creatures often have enormous livers relative to their body size. These oversized livers store lipids essentially, they're living oil tanks. In an environment where food is scarce and unpredictable, being able to store energy efficiently is crucial. Some deep-sea sharks have livers that make up over 20% of their body weight, compared to less than 5% in most terrestrial animals. It's like carrying a fuel tank that's a quarter of your body mass. But in the deep sea's energy-poor environment, this strategy makes perfect sense. Survival through storage. The deep ocean has communities living entirely on sunken wood. When trees from land get washed into the ocean and sink to the deep sea floor, they create woodfalls similar to whale falls. Specialized bacteria, fungi, and invertebrates colonize these wood islands, breaking down the cellulose and lignin. Some of these woodfall species are found nowhere else, having evolved specifically to exploit this resource. It's a reminder that the deep sea and terrestrial world are connected. Trees that grew in sunlight end up feeding communities in eternal darkness, bridges between worlds. Deep sea creatures are being found with microplastics in their tissues at every depth sampled. Plastic particles have been detected in animals from the surface to the hadal zone in every ocean basin. These particles enter the food chain when animals mistake them for food or consume prey that has ingested plastic. The long-term consequences are still unknown, but early studies suggest microplastics may affect feeding behavior, reproduction, and survival. We've altered the chemistry of the entire ocean, top to bottom, in less than a century, pollution permeating everything. Big fin squid, those strange creatures with enormously long tentacles, have only been seen a few dozen times, all captured on deep-sea cameras. No one has ever collected a specimen for study. Everything we know comes from video footage and a few immature specimens. We don't know how they reproduce, what they eat, how long they live, or how many species exist. They're mysteries that glide through the twilight zone, barely glimpsed, barely understood, reminders of how much we still don't know, question marks with tentacles. The deep ocean contains mountains made entirely of living organisms. Deep-sea coral reefs, built slowly over thousands of years, can form massive structures that rise hundreds of feet from the seafloor. Unlike shallow tropical corals, these don't need sunlight. They capture food from passing currents. These reefs provide habitat for countless other species, creating biodiversity hotspots in the deep sea, but they're extremely fragile. Bottom trawling dragging fishing nets across the seafloor can destroy in minutes what took millennia to build. Instant destruction of ancient creation. The deep sea contains lakes of liquid carbon dioxide. In certain areas where CO2 seeps from the seafloor and accumulates in depressions, the pressure and temperature keep it in liquid form. These CO2 lakes are toxic to most marine life, killing zones on the ocean floor. But specialized organisms have adapted to thrive at their edges, bacteria and archaea that can tolerate conditions lethal to most life. Scientists study these areas as analogs for what Earth's oceans might become if we continue adding carbon dioxide to the atmosphere, windows into possible futures. Yeti crabs live clustered around hydrothermal vents in the deep southern ocean. These pale, blind crabs have hairy chests and arms. The hair is actually seta bristles that host colonies of bacteria. The crabs wave their arms in the vent water, cultivating these bacteria, which they then scrape off and eat with specialized mouthparts. It's underwater farming, agriculture in the abyss. The bacteria detoxify poisonous chemicals in the vent water while also serving as food, a symbiotic relationship that allows Yeti crabs to thrive in one of Earth's most extreme environments. They look like they're perpetually waving, conducting some underwater symphony only they can hear. Farmers tending invisible crops. Viperfish have teeth so long they can't fit inside their mouths. Their fangs protrude even when their jaws are closed, and the longest teeth actually curve back toward their eyes. When hunting, viperfish swim at high speed toward prey and impale them on these massive teeth, which angle backward to prevent escape. Viperfish also have hinged skulls that allow their heads to tilt back, creating an even wider gape to swallow prey that might seem too large. They look like nightmares, but they're perfectly adapted predators. Midnight hunters in a midnight world form following function to extremes. The deep sea has fields of black smokers that look like alien cityscapes. In areas of active seafloor spreading, dozens or even hundreds of hydrothermal vents cluster together, their chimney structures creating dense vent fields that researchers have nicknamed vent cities. The Lost City hydrothermal field in the Atlantic features white carbonate spires reaching 200 feet tall, the tallest hydrothermal vent structures ever discovered. Skyscrapers of stone. These fields are hotspots of life in the deep sea, oases in the desert. And scientists believe similar vent systems might exist on ocean moons like Europa or Enceladus, making them prime targets in the search for life beyond Earth, templates for alien worlds. Deep-sea anglerfish males are parasitic in the most extreme way. Some species of males don't just temporarily fuse with females, they permanently lose their identity. Their circulatory systems merge completely, their internal organs degenerate, and they become little more than sperm-producing appendages on the female's body. DNA analysis of females has found chimeric tissue parts of their bodies containing DNA from multiple males, genetic colonization at the cellular level. It's a reproductive strategy so bizarre it challenges our definitions of individuality. A merger so complete that male and female become a single composite organism to becoming one, literally. The deep ocean floor is covered with tracks and trails from creatures we may never identify. Cameras lowered to the seafloor have captured images of mysterious trackways, some spiral, some straight, some meandering, and we can only guess what made them. Some tracks are clearly from known creatures like sea cucumbers or brittle stars, but others defy explanation. There are spiral patterns that look almost intentional, as if something was searching methodically, and strange drag marks that suggest creatures we haven't seen. The seafloor is a vast mystery novel written in sediment, most pages still unread, stories untold. Greenland sharks are often blind because of parasites. A species of copepod attaches to the shark's corneas and feeds on the tissue, often causing permanent damage and blindness. Yet the sharks carry on, hunting by smell and other senses in the already dark water they inhabit. Some researchers speculate the copepods might even help the sharks by attracting bioluminescent prey, though this remains controversial. What's certain is that these ancient sharks are unbothered by blindness, successful hunters despite it, proof that in the deep darkness, eyes are optional, other senses suffice. The deep sea contains more biomass than tropical rainforests. While rainforests are famous for their biodiversity, the number of different species, the deep ocean likely contains more total living matter when measured by weight. Most of this biomass consists of microorganisms, bacteria, and archaea living in the sediment and water. But even excluding microbes, the deep sea holds staggering quantities of life. It's just spread out over such a vast area that we rarely appreciate the scale. Imagine all the deep sea fish, all the invertebrates, all the gelatinous creatures spread across an area larger than all continents. Combined, it adds up to more life than in any terrestrial ecosystem. Abundance in vastness, a long, peaceful breath. And now, dear listener, we've reached the bottom. We've descended 7 miles through darkness, through pressure, through cold. We've met creatures that glow and creatures that merge, predators with invisible light and farmers that cultivate bacteria. We've seen mountains taller than Everest and waterfalls that dwarf Niagara. all hidden beneath waves we sail across without knowing what lies below. The deep sea has taught us something profound. It's shown us that life doesn't need our conditions to thrive. It doesn't need sunlight or warmth or gentle pressure. It doesn't need to look familiar or behave in ways we understand. Life finds a way, not through conquest, but through adaptation. Not through force, but through patience, measured in millions of years. Every creature we've met tonight is a solution to a problem we can barely comprehend. How do you survive in eternal darkness? You make your own light. How do you find a mate in an ocean of emptiness? You merge with them permanently. How do you eat when food falls from the sky only once a season? You wait, you conserve, you endure. These aren't monsters. They're miracles, each one a testament to life's creativity, to evolution's endless experimentation, to the fact that wherever there's the faintest possibility of existence, something will evolve to fill that space. The deep sea is extreme, yes, but it's also stable, constant, ancient, and in that ancient constancy, life has refined itself to forms that seem alien to us but are perfectly, beautifully suited to their world. You are connected to these creatures in ways you might not realize. The oxygen in the breath you just took was likely influenced by deep ocean currents. The carbon in your body has cycled through the deep sea many times over billions of years. The stability of Earth's climate depends on the deep ocean's ability to absorb heat and carbon. When we explore the deep, we're not studying some distant, irrelevant realm. We're studying the engine room of our planet, the foundation upon which our surface world rests. And there's something humbling in knowing that beneath the waves, in places we rarely think about, in darkness we'll never personally visit, this whole other world exists. Billions of creatures living their lives, hunting and hiding, reproducing and dying, playing out dramas we'll never witness. The deep sea reminds us that Earth is larger and stranger and more wonderful than we can possibly imagine from our small corner of the surface. As we slowly ascend now, rising back toward the twilight, then toward the faint blue, then finally toward the sun, carry this with you. Mystery is not something to fear. The unknown is not empty or hostile. It's full of wonders waiting to be discovered. The deep sea has kept its secrets for billions of years, and it will keep many of them for billions more, and that's beautiful. We live on a planet that still has places like the Hadal Trenches, where 4 humans have visited the deepest point in over 60 years. We live in an age where new species are discovered on every expedition, where entire ecosystems were unknown until 50 years ago. We live in a time when there's still genuine mystery in the world, still frontiers to explore, still questions without answers. Let that thought comfort you as you drift toward sleep. You live on a planet of wonders. Beneath the ocean you've seen from beaches and boats, beneath the waves that crash and foam, there's a world of bioluminescent beauty, of ancient survivors, of life persisting against all odds. And it's all still there, right now, as you close your eyes. Snailfish gliding through the Mariana Trench, Dumbo octopuses flapping their ears in the darkness, glass sponges filtering water the same way they have for millions of years. The deep sea doesn't need us to exist. It was here long before we evolved, and it will be here long after we're gone. But it offers us something invaluable: perspective. It shows us that our way of living isn't the only way, that our understanding of life's possibilities is limited by our own experience, that there's always more to learn, more to discover, more to wonder at. Thank you for descending with me tonight. Thank you for your curiosity, your openness to mystery, your willingness to explore the unknown from the safety of your bed. If you enjoyed this journey, a gentle like helps others find their way here too. Subscribe if you'd like to explore more wonders together. But more than that, just rest now. Let the deep sea's lessons wash over you like gentle currents. Let its mysteries comfort you rather than disturb you. Let its ancient patience slow your heartbeat, slow your thoughts, slow everything down to the pace of life in the abyss, where time moves differently and everything happens in its own slow rhythm. The creatures of the deep don't rush. They can't afford to. Energy is too precious, food too rare. They move through their world with deliberate grace, with patience we can barely comprehend. Tonight, as you fall asleep, be like them. Don't rush toward unconsciousness. Drift toward it, slowly, peacefully, like marine snow falling through the water column. You are safe. You are warm. You are at the surface where you belong, where the pressure is gentle and the oxygen is abundant. But you've touched the deep tonight. You've glimpsed its wonders. And somewhere in your dreams, perhaps you'll swim there again, through the twilight zone, where lanternfish migrate, past the midnight zone, where anglerfish wait with glowing lures, all the way down to the bottom of the world, where snailfish dance in darkness and tube worms bloom like flowers. Sleep well, dear explorer. The ocean will still be there tomorrow, holding its mysteries, keeping its secrets, waiting patiently for us to understand just a little bit more. Good night.